Welcome back to part 8. In this video we're going to talk about pixels, we're going to learn about the XY grid, and we're going to get our character moving across the screen every time we get a correct answer so we can win the game. The next thing we want to do is, remember in the beginning when I showed my demo game, the character on the screen actually moved. Each time it moved one step closer each time we got a correct answer. So now we're going to start to think about how that happened. Over here on your right hand side, back to the stage, you'll see you have your characters, you see you have the background, you have nice clouds and green and blue sky, and that's what we think of as the background. But that's not actually what the computer sees. Remember that the computer works in pixels, and what the computer actually sees are pixels. So all screen images are made of pixels, and pixels are basically just little squares of color. Here you can see from this image from Stack Overflow, if you zoom right in on the image on the screen, you then see it translates into little blue and red squares. Another example would be some of this Minecraft art. If you look over here on the right, you see the sword, which looks like a pretty cool sword, but when broken down you can see it's really just a bunch of squares formed together to make a picture. And here we have creeper, and when you look closer you see he's not actually a creeper, but he's just a collection of squares. So the computer doesn't know that that's a lovely sky with clouds and grass. What the computer sees are pixels. And take it one step further, the computer not only sees the pixels but knows exactly where those pixels are on the screen. So this is a two-dimensional game, and whenever there are two dimensions, the dimensions are of course x and y. So we have the x-axis and the y-axis. Yes, it's true. Video game building relies on math. Remember back to your lesson on the XY grid. The x is the horizontal axis, so running left, right. The y-axis is the vertical axis, so running up and down. And we're going to talk more about that in a few minutes. So the computer knows there are pixels located somewhere in the XY grid. And that's what a two-dimensional game is. It works on the XY grid. So what does that really mean to you, and why do you need to know that? For a moment, let's go here under New Backdrop. That will open up the pre-made Scratch backdrops, and we're going to arrow down. Scratch actually gives us one called the XY grid. I'm going to select that. When I select something, you'll see that the blue box surrounds it. And I'm going to click OK. I'm going to change my background from my beautiful, lovely sky to now the XY grid. Because no matter what background I have up there, the computer is always thinking in terms of the XY grid. And if we look over here on the larger image under backdrops, we can see that the X runs horizontally. X in Scratch starts at the 0 and goes up to 240 characters. Back to 0 and down to 240 characters. So the length of X is actually 480, and we all know about the XY grid from math. So here's a way we bring math to the real world, and I love the XY grid. And then when we think about the vertical axis, the y-axis starts in the middle point at 0, goes up to 180, and also goes down to 180. So 180 and 180 are 360. So the actual screen is 360 pixels vertically and 480 horizontally. Now, why do you need to know that? Very, very, very important. If you look over here, you can remember I told you you can click your left mouse button, hold it on a character and move it around. As I do that, keep an eye on these numbers right here. See how there's an X and a number and the Y and a number? Watch how they change. They are actually telling you where on the XY grid my mouse is. My pointer is, I guess. My pointer is. And in turn, the character. So you'll know here I'm at just about 0, 0. If I go way up to here, my X number is staying low, close to the 0. My Y has gone up and down. Every spot, every pixel occupies some location on the XY grid. And the reason I'm telling you that is because when the game starts, we want our character to start in a certain location, and we actually want our character to move a certain number of pixels along the XY grid. So for the moment, let's select our backdrops. So click here on backdrops, and you'll see these are the choices we have. There's a blank one for some reason. Let's click X and get rid of that. So we can go back and forth between the beautiful blue sky and the XY grid. And they're both always there, it just depends on which one is showing. So for the moment, let's leave it to our beautiful sky. And I actually want my character, I think, to appear right about here. And I want to make sure every time my game starts, my character starts in that same position, because that's the starting point of the game. So to do this, I need an event, because remember, when the flag is clicked is an event. I'm going to drag that over to my workspace, and all I want to do is say when the flag is clicked and the game is started, all of this other thing is happening, but I want to make sure my character resets to this position. And Scratch has given us a very easy way to do that. We go under the Motion tab, and you're going to see this line of code that says go to X and a certain character, certain digits, and Y and certain digits. And now you can see that the numbers are at X is -163, so we know that's over to the left of the screen, just knowing about the X axis. And Y is -74, so we know that indicates it's down below the center point of the Y axis. If I move my character, watch what happens to those lines of code. They've changed. So that is a great feature that Scratch has allowed. It actually, wherever your character is, that's what those numbers will automatically be. So let's put them where we want them to be. And we're going to say every time the game starts, we want them to go to X coordinate and Y coordinate, those two locations. And I clicked that together. I could have put it anywhere. I could have added to here. I didn't need to give it its own block of code, but I love keeping things separate because then if you're looking for it later on, you can always find it. So I'm going to say when the flag is clicked, go to X -161, Y -72. And let's check where that looks like on the backdrop. And we can see that's in the negative of both, the negative quadrant there, the lower left-hand quadrant of our XY grid. Now what we want to think about is how do we move our character over and over and over and finally get to the rocket ship, because that's where we want to be. And when do we move our character? We only move our character when the person gets a correct answer. So if we zoom in on our code, we can remember right here, we move our character at the same time that we score, don't we? So to make that easier to find on our code, I'm going to drag a say block, and I'm going to say you get to move closer to, let's just say you get to move 1 space. So every time the score changes by 1, we're going to add this line of code that says you get to move 1 space. And down here, remember when they had a second chance, we want to also say you get to move 1 space. We want to move the character a certain number of pixels along the screen. So let's go back to this, come over to scripts, select our character. Now here's kind of where we guess. We're not really sure. So maybe 60 pixels. We kind of want to go from here in 4 steps. So 1, 2, 3, 4. I'm just taking a guess. So I'm going to go under motion and I'm going to change X by 60 because I don't want to lift him up any because he's only going to move along the horizontal axis. So every time we get an answer right, I want to change my X value by 60. So I'm going to go here under the Motion tab and I'm going to grab the block of code that says change X by 60. And I need to put that here after I told him he gets to move. And again, it opens up, see the white space there? It's going to allow me to move in. And I'm going to say change X by 60. And I'm also going to do that if he gets it right on the second try. So I need the next lines of code that says change X by 60. And where did he get it right? Right here. Okay, so let's test that out. I'm going to go back I'm going to select this backdrop. It's a little less busy. And let's start our game over. Hello, my name is Sally. What's your name? Kim. Hello, Kim. Let's get started. Broadcast. So what is product of 5 times 6? So ideally, if I get this correct, I want my character to move right about here. So let's give it a try. I'm going to type in 30. Congratulations, that's correct. You get to move one space. And my character moved. Perfect. So what is the product of 10 and 9? I'm going to say 90. Enter. What happens? I got it correct. I get to move one space. Boom. Moved again. What is the product of 1 and 2? That is 2. So let's hit enter. And he's going to move again. Excellent. What is the product of 9 and 6? I know that's 54. Hit enter. Excellent. So now I've gotten 4 correct, which is kind of what I wanted. No, I actually wanted to get 5 correct. So I could have made that a little bit less. I didn't want him to come quite so far. So I'm going to go back to my script and show you what I mean. So instead of 60, I'm going to change x by 40. I don't want him to go quite so far because I want to get 5 correct before he touches the spaceship. So let's press stop. We'll press play again. Hello, Kim. Let's get started. What's the product of 10 and 1? 10. Correct. Move one space. What's the product of 10 and 6? We're going to say 60. That's correct. Move one space. What's the product of 6 and 2? 12. And sometimes in computer programming, it may seem like it takes a long time, but it's all about debugging. 4 times. Excellent. And that didn't take me quite as far as I wanted. So I think instead of saying if it's less than 4, I actually want to say if it's less than 5. So after 5 questions, you can see that these two characters are not quite touching. Instead of 40, I'm going to try 50. And sometimes it's just about trial and error. You just have to try it. You'll notice that he went back to that start every time. What is your name? Because I said when it starts, go back to that space. 9 and 2 are 18. 2 and 8 are 16. That's 2 correct. This will give me 3 correct. Getting closer. 4 correct. And hopefully 5 correct. They should be touching. They are perfect, and that's exactly what I want to happen.